Welcome to my channel Mathematical Clinic of Subhasja. In this lecture we are going to do numericals of limits of algebraic function taking the form infinity minus infinity. Actually, if any algebraic function takes the form infinity minus infinity, then to obtain its limits we simply rationalize. To find the limit of the algebraic function taking the form infinity minus infinity, we'll have to rationalize. After the rationalization, two types of numerical comes. In one, if you simply substitute x equal to infinity, replace x by infinity and get the answer. And another one, if you substitute x equal to infinity, then it takes the form infinity upon infinity. Let us do some of the numerical. The first numerical one is limit x approaches to infinity root x minus 3. If you substitute x equal to infinity here, this one is infinity and this one will be also infinity. So the form infinity minus infinity. It is an algebraic function taking the form infinity minus infinity. We must write that here. This function takes the form infinity minus infinity when x equal to infinity. So we simply rationalize it. Limit x approaches to infinity root x minus 3 as it is. Let us rationalize. We multiply by conjugate. Root x plus root x minus 3 divided by root x plus root x minus 3. Simplify it, it will be limit x approaches to infinity. A minus b into a plus b will be a square minus b square divided by root x plus root x minus 3 as it is. X and x will cancel. So we will be left with limit x approaches to infinity 3 upon root x plus root x minus 3. Let us substitute x equal to infinity now. It becomes 3 upon infinity's root is infinity. Infinity minus 3 is infinity and its roots is infinity again. So it is 3 upon infinity plus infinity is infinity and positive number divided by infinity is 0. So 0 is the answer of this question. This is the first type of numerical. Algebraic function taking the form infinity minus infinity, we have rationalized. After rationalization, we simply substitute x equal to infinity and get the answer. This is not taking the form infinity upon infinity. Rather, after substituting x equal to infinity, we get the answer. This is the first type of numerical of algebraic function taking the form infinity minus infinity. Let us move to the second type of numerical. Consider this numerical one. This one is also an algebraic function. If you substitute x equal to infinity here, infinity into infinity minus infinity. So, conclusion, this is also taking the form infinity minus infinity. So, same mechanism. This will take the form infinity minus infinity. So, by the same mechanism, we rationalize it to get the answer. So it will be limit x approaches to infinity root x as it is, root x minus a as it is. Let us rationalize it. So we multiply by the conjugate of this expression, root x plus root x minus a divided by same root x plus root x minus a. It will be limit x approaches to infinity as it is, root x as it is, a minus b into a plus b will be a square minus b square divided by root x plus root x minus a as it is. X and x will be cancelled and you will be left with limit x approaches to infinity a times root x divided by root x plus root x minus a. Now if you substitute x equal to infinity here, then it becomes infinity and denominator also infinity upon infinity form. Now this function is taking the form infinity upon infinity. So we'll have to move towards the mechanism of infinity upon infinity. The last video we learned that if an algebraic function takes the form infinity upon infinity, then to determine its limit, we divide by the maximum powered variable. And here maximum powered variable involved is root x. So we divide each term by root x. A root x by root x, even root x by root x, and even root x minus a by root x. Here root x will cancel here also. So you will be left with limit x approaches to infinity. In the numerator simply a root x by root x is 1, and here write in the single root and separate the term by x. It will be x upon x equal to 1 minus a upon x. Now substitute x equal to infinity. It becomes a in the numerator as it is, 1 as it is, root under 1 minus a upon infinity is 0. This one is a upon 1 plus root of 1 is 1. So the answer is a upon 2. That's all.